Okay, so starting lesson 4.3, it's a big one. It's kind of long. It's a very important lesson. All right, so we're still talking about area and definite integrals. Who remembers what I said a definite integral is? It's still this integral sign. It means you're going to be taking the antiderivative, but you will have a number at the bottom and a number at the top. So it means we're finding the area between two specific numbers, not just a general antiderivative. Okay, so to find the area under a curve, we can take the antiderivative of the function. We've talked about that. Then we evaluate the antiderivative at the upper boundary and subtract the antiderivative evaluated at the lower boundary. We've talked about that. Okay, so here's an official definition. Let f be any continuous function. What does continuous mean? Yeah, like you can draw it without picking up your pencil. No breaks in it, no jump discontinuity, no vertical asymptotes, things like that. Over the interval from a to b. So this would be a lower x boundary and an upper x boundary. And capital F is the antiderivative of that function. Then the definite integral of the function from a to b is written like this. And then the way we evaluate it is we take the antiderivative evaluated at that upper number, subtract antiderivative evaluated at the lower one. And we did a little bit of that the other day. Okay, so the area between the x-axis and the graph of a non-negative continuous function, that means if the function is above the x-axis, of y equals f of x over the interval from a to b is found by evaluating the definite integral. That thing we just talked about, where f is an antiderivative of little f. If a function has areas both below and above the x-axis, the definite integral gives the net total area, or the difference between the sum of the areas above the x-axis and the sum of the areas below the x-axis. What does a net total mean? Yeah, like if you have positives and negatives, then you add them together. Okay? If there is more area above the x-axis than below, then the definite integral will be positive. If there is more area below the x-axis, then the definite integral will be negative. If the areas above and below are the same, then the definite integral will be 0. Okay, so a new twist on things today. Sometimes the area is considered to be negative. So, for example, if I had a function, let me go back to this first page. There's a little bit of space over here. Okay, let's say that I had a function that started out here but then dipped below. Okay, this area up here would be considered positive. This area down here would be considered negative. Now, how can you have negative area? I know area technically is kind of like distance and it's positive, but when we're talking about a graph and change in a graph, what did we use to represent heights of the rectangles that we drew? We use the y-coordinates, right? So all of these y-coordinates are positive, but when you get down here, those y-coordinates are negative. So if I were calculating area of rectangles down here, they would technically come up being negative because the y-coordinates are negative. So this means if you have more positive area than negative, once you add them together, the end result will be positive area. If you have more negative area, so let's say the opposite happened, and I had a graph that was like that, then I have a little bit of positive, a lot of negative, that net area would be negative. Can you think of a graph that would be equal above and below? A sine curve, yeah. So if I were finding the area of a little part of the sine curve, and I had equal positive and negative, then those just basically cancel out, and you have a net area of 0. Okay? All right, so kind of like velocity can be positive, negative, or 0, so can net area. All right, find the area under the curve of y equals x squared plus 1 over the interval -1 to 2, then find the area over the interval 0 to 5. Okay, so start with your function. What does this function look like? Parabola that has been what? Shifted up 1. Okay, so let's draw a little sketch. I'm going to draw my picture up here. Now this graph has nothing below the x-axis, so I don't need to worry about this negative area and positive area here. Okay, let's go to -1, 1, 2. Okay, so I have this point to this point. I want the area under the graph between -1 and 2. This is a lower x value and this is an upper x value. So this is where you cut off the area. I want the area here. Now, that is not a region that we have a geometric formula for. So using our antiderivatives, like we just talked about, we'll actually find the exact area. Okay, so I'm going to set up for this one right here, and then we'll take care of that one in a minute. The integral from -1 to +2 of this function, x squared plus 1 dx. And this, all these symbols actually mean this. Sum up, it's an elongated S. It's not using the sigma Greek letter, but this elongated S. So sum up, add up a bunch of areas of width times height. dx means how far this is, and the height is whatever those y coordinates are. So it's like take a whole bunch of tiny little rectangles and add up their area, starting at -1 and stopping at 2. So it's kind of like that sigma notation. It's just different notation, but it means the same thing. Okay, but we're going to get this exact area not with little bitty rectangles. We're going to do the antiderivative. So antiderivative of x squared is x cubed over 3 plus x. And then we do this vertical bar, which means evaluated from -1 to 2. Okay. Sub in the first one, the highest one, the biggest one, the one on top. 2 cubed over 3 plus 2. Andrew, you're going to fall over when you fall asleep there. Subtract, sub in the smaller or the lower number on the bottom. Now, if I'm cubing a negative, if I'm raising a negative to any power, I always use parentheses. Here we go. Sub in upper minus sub in lower. And from there, then we're just crunching numbers. So that's 8/3 plus 2 minus -1/3 plus -1. Okay, so that's 8/3 plus 2 plus 1/3 plus 1. Distribute that subtraction there. Changes the sign of both of those. What's 8/3 plus 1/3? 9/3, which is really 3. Plus 3 is 6. So we get an area of 6. Question? Okay, for the second part, find the area over the interval 0 to 5. Okay, I'm not going to regraph this, but basically what I'm doing is shifting the region that I'm finding the area of. I'm starting at 0 and shifting it down here to 5. So I should expect more area, clearly. Okay, so second part, find the interval integral, my bad, on the interval 0 to 5 of the function. So I'm finding the area under that parabola between 0 and 5. Okay, we already know the antiderivative. We just found it from 0 to 5. And remember, when you're doing these definite integrals, it's a definite integral when you have numbers here. We don't bother with the plus c, because if I had a plus c here and a plus c here, whatever c is, those are going to just subtract out. So we just leave them off. I mean, if it makes you happy to include it, you can. They should end up disappearing in the end. Okay, sub in the big number. Minus, sub in the little number. Zeros are always nice to sub in. They don't always give us 0, but they usually give us something simple. Okay, so 5 cubed is 125 over 3 plus 5, and all that is just 0. So 125 plus 15 thirds is 140 thirds. Well, that's not going to be a terminating decimal, so I'm just going to leave it. Question. Okay, next one. This is a definite integral, but notice they're just these generic values a to b. So I'm probably not going to end up with just some number like 6, like we did above. But I'm going to set it up the same exact way. So the integral from a to b of x squared dx. What's the antiderivative of x squared? 1/3 x cubed, or x cubed over 3. I'll write it that way this time. Evaluate from a to b. Okay, now b is the bigger number because it's on top. 1/3 b cubed minus, sub in the smaller, 1/3 a cubed. Can I do anything with that? Not really. I mean, not to simplify, I could write it this way if I preferred that. Or, once I have it written that way, I could actually see that I could make it into one fraction because I do have common denominators. But that's all. Without knowing what a and b are, that's all that we can do. You with me, Gavin? Question? All right then. Okay. You do a for me, and then I'll jump in with b in just a minute. But set up a. We'll set up b and c together. Tackle a for me. Talk to your neighbor and set up a. Over 6. Actually, let me just show you. There we go. Okay, so that's all the work. If you need to check every step there, negatives are easy to get you stuck on this one. Anytime you're raising a negative to a power, be sure you put that negative in parentheses. This here gives you a negative, but you're subtracting, so then it becomes positive. So watch out for the negatives and subtractions. Yes?
Is that like a different packet? Because I turned and like when I looked back, it was like all the work was shown.
Yeah. Uh-huh.
Okay.
Yeah, I already had it worked out.
I saw like you just wrote out the problem. I turned my head and when I looked back.
I'm really fast, Andrew. Okay, so let's do part B. Let's just put 85 over 6. Okay, part B. The integral from 0 to 3 of e to the x dx. Okay, what is the antiderivative of e to the x? e to the x. Evaluate from 0 to 3. Okay, so we're going to sub in the big number first, e cubed. Subtract, sub in the lower number. What is e to the 0? 1. So I would just totally leave this answer e cubed minus 1. So it looks a little scary, and you're like, oh my gosh, it's got an e in it, but it's actually super easy. Question on that one. Okay, now let's look at the third one. The antiderivative from 1 to e of 1 plus 2x minus 1 over x dx. Okay, assume that x is greater than 0. That will play out in a minute. I'll show you why that's important. This little clarification here. I'll explain that in a second. All right, let's take the antiderivative. 1's antiderivative is x. 2x antiderivative is x squared. 1 over x. What's that antiderivative? Natural log. Okay, and all of that is evaluated from 1 to e. How much is e? What's that approximation for e? 2.72. A little less than pi. Okay, so we're going to sub e in. Now I've got 3 terms here, so I'm going to put these in brackets. I have e plus e squared minus natural log of e. Subtract 1 plus 1 squared minus natural log of 1. Okay, so let me go back and explain why it says assume x is greater than 0. Anytime you have a logarithm, this thing right here that you're taking the log of, called the argument, it has to be positive. So that's why they're saying assume x is positive, because that would only be defined in that logarithm. Yes?
So would that be e to the 0 in the very beginning?
Because we're subbing this in for x, so it just becomes e.
So if you plug it in, you just plug in that x to the x and you just leave the top line.
You mean e to the x?
Right.
Oh, you could make it a 1. But I'm just going to leave the e's. I'm not even going to get decimals for those. I'm going to say that's e plus e squared. In the final, I might get a decimal. What is the natural log of e? 1. Because remember, with logarithms, natural log has a base of e. So if I have natural log, which is base e of e, equals what? E to the 1 equals e. So the natural log of e is 1. Okay, I'm going to distribute this negative. Minus 1 plus, what's the natural log of 0? What's the natural log of 1? 0. Because e to what power gives me 1? E to the 0 gives me 1. Okay, so let's see what combines here. I have e plus e squared. Oh, none of those cancel. Minus 3. That's it. So I could leave it that way. That would be exact. If I want a decimal for it, then I could type it in the calculator and get a decimal. Question on that one? All right, let's do one more, and then we'll stop on our notes there and just work on homework. Okay, set this one up for me. I will come around and check your answers, and if your answers are good, then you can start on your homework. Already done. Let me do it. I actually don't have the answer for this one. So, okay, here's our answer of 102, and we're going to stop the notes at this point and work on today's homework assignment.